Hello, everyone. Today, I just wanted to go through some of the questions, one from the lab and a couple from the homework, and just clarify a few things and maybe help us out a bit. So, first up, I have up here question number 16 from Lab 2. This question is kind of confusingly worded here. It says an urn contains 5 red balls, 7 yellow balls, and 8 white balls. How many different ways can you pick 2 red balls? So we're kind of working with some assumptions here that our assumptions are we can see inside the urn. We want to choose 2 red balls. So we want to just choose 2 red balls. We're ignoring the others. And so in this case, it might be helpful for us to imagine that these balls are like labeled in some way. Like maybe they are numbered or given a letter of the alphabet or something. So we'll say, let's say, assign each a number. Or a letter. And I think that when we do this, this problem will become a little bit easier. So again, we're just trying to choose 2 red balls, ignoring that the others even exist. Really, this problem should have been an urn contains 5 red balls. How many different ways can you pick 2 balls? That's essentially how we are treating this problem. Next up, I have a question from the homework. And this question, this says, in a large population, 55% of the people have been vaccinated. If 3 people are randomly selected, what is the probability that at least one of them has been vaccinated? Give your answer as a decimal to at least 3 places or a fraction. So in this type of problem, we want to use this idea of complementary events. Remember from the chapter that if 2 events are complementary events, then to find the probability of one, we just subtract the probability of the other from the number 1. The notation used for the complement of A is not A or A and then this superscript C. And the probability of A plus the probability of not A is equal to 1. So in this case, I know that if the probability of vaccinated is 0.55, the probability of not vaccinated is 0.45. This is because the probability of not vaccinated. Oh, sorry, I just realized I need to zoom out a little bit here. In this case, the probability of not vaccinated is 1 minus the probability that someone is vaccinated. The reason why this is important to this problem is because we're looking at the probability that at least one person is vaccinated out of the 3. This is the probability that one or more people are vaccinated, or that so this is the probability that one or more are vaccinated. And this is the same as 1 minus the probability that none are vaccinated. Because the probability that one or more are vaccinated includes the probability that one is vaccinated, the probability that 2 of the people are vaccinated, and the probability that 3 of the people are vaccinated. The complement of this would be the probability that none of the people are vaccinated. So these two have to add up to be 1. And it's going to be easier for us to find the probability that none of these 3 are vaccinated. Because we said that the probability of someone not being vaccinated in this case is 0.45. This is 1 minus 0.45 cubed. Because this is the probability of each person not being vaccinated is 0.45. I guess we could write this out as 0.45 times 0.45 times 0.45, like this. This is 1 minus 0.45 cubed. So we're finding here 1 minus the probability that none are vaccinated. The probability that none are vaccinated is the probability that the first person is not vaccinated times the probability that the second person is not vaccinated times the probability that the third person is not vaccinated. And I'm going to use a calculator to find what this is. This is 1 minus 0.091125. Which is 0.908875. And this is the probability that at least one of these 3 people is vaccinated. And for the purpose of typing this into the homework, it says give your answer as a decimal to at least 3 places. So if you typed in this exact number, this would be perfectly fine. Or you could round this to 0.909. And moving on to the third problem I wanted to talk about. Here we have another homework problem. A CBS News poll conducted June 10th and 11th, 2006 among a nationwide random sample of 651 adults asked those adults about their party affiliation, Democrat, Republican, or none, and their opinion of how the U.S. economy was changing, getting better, getting worse, or about the same. The results are shown in the table below. It says to express your answers as a decimal and round to the nearest 0.001. If we randomly select one of the adults who participated in the study, this says compute affiliated with neither party. I think that we could do that. All you have to do is find all of the people in the none row, add them up, and divide by the total number of adults, which we know is 651. The probability that someone thinks that the economy is the same idea here. You add up everything in the same column this time, though, and you divide by the number of adults. What I really wanted to look at is the next two parts here. The probability that someone thinks that the economy is the same, given that they are affiliated with neither party, and the probability that someone is affiliated with neither party, given that they think that the economy is the same. So these are conditional probabilities. You'll see in 4.3. Conditional probabilities are probabilities that are calculated after information is given. This is where we want to find the probability of event A given that event B has happened. If we know that event B has happened, then you don't have to consider the rest of the sample space. You only need the outcomes that make up event B. Event B now becomes your new sample space, which is called the restricted sample space R. If you always write a restricted sample space when doing conditional probabilities and use this as your sample space, you will have no trouble with conditional probabilities. The notation for conditional probability is probability of A given B. So this line, this vertical line, is read as given. The event following the vertical line is always the restricted sample space. So for this problem, we are going to restrict our sample space to whatever comes after this vertical bar. We will no longer be dividing by this 651 for these problems involving the conditional probability. For instance, the probability that someone believes that the economy is the same, given that they are affiliated with neither party. For this one, we are restricting our sample space to only people who are affiliated with neither party. So our sample space will only be this none row. So the total here is going to be 21 plus 90 plus 118. It's good for us to know this total. This is 21 plus 90. This is 229. And we want to find the probability that someone believes that the economy is the same, given that they are affiliated with neither party. Now we just have to find the overlap of the none and same, which is just this 90. So in this case, this is 90 out of 229. The probability that someone believes the economy is the same, given that they are affiliated with neither party, is 90 out of 229, because there are 229 people in this restricted sample space, and 90 of these people believe that the economy is the same. And if I type this into a calculator, I get about 0.393. Now we have to be careful because these conditional probabilities, you can't just flip them around and get exactly the same thing. So the next thing is, it looks like it's the same thing but flipped, but we're going to see that we're not going to get exactly the same answer here. The next one is the probability that someone is affiliated with neither party, given that they believe the economy is the same. In this case, we want to restrict our sample space to the people who believe that the economy is the same, which is this column. We want to find the total number of people in this column. It's going to be 104 plus 87 plus 90. Which is 281. And we want to find the probability that someone is affiliated with neither party, given that they believe the economy is the same. And that would be the people who are in the none row. So 90 out of the 281 people who believe that the economy is the same, 90 of them are also not affiliated with any party. And so we find what 90 divided by 281 is. And this is about 0.320. I just wanted to go through an example of this problem. I know this is a type of problem that a lot of people have had trouble with in the past. Have a great one, everyone.